All right, welcome to pre-calculus. We are going to be talking about double angle formulas today. This will be a couple of sessions though. So let's go ahead and get started here. And we have, so double angle formulas, the derivations are actually a bit easier than the sum of angles, okay? So if you remember the sine, right, of A plus B is equal to sine A cosine B plus cosine A sine B. Okay. What if we just had two of the same angle? So what if we sine of 2A? I'm going to pull this revolutionary idea here that A plus A would be 2A, okay? But we have a sum of angles formula to deal with this, okay? So why don't I do it this way? I'll say sine, and then we'll do an A plus degree, A plus B, okay? And this is going to be, sine of A cosine B, cosine, let's get rid of that. So cosine B, okay, sorry. So while they're doing the colors, I didn't realize what the colors were for. So this is cosine of this A. Okay, so we have a red A, we have a blue green A. Okay, so this is cosine of this A plus, and then look at this, we've got a cosine of the first one. So this is going to be, right, it's going to be cosine of the first one, okay, times sine of the second one. Okay, so there is our formula here with just the A's and B's, right? The red A's with the first one, green A's with the second one. But notice it's just cosine A, or sine A, cosine A, cosine A, sine A, right? They're really the same thing. So this is just equal to 2 sine A cosine A. Well, what is wrong with my guy here today? But all right, but that's our formula for cosine of 2A is equal to, okay, is equal to 2 sine A cosine A. Right? You have no idea how annoying it is. Hold on. Pause this for a second. Hopefully that fixed it. Who knows though? Okay, same thing with cosines. Okay, we have cosine of 2A, right? Remember, again, we have cosine, I will do the colors. We have cosine of A plus A. Okay, this is equal to, okay, cosine A cosine second A minus sine A sine second A. But this is just cosine squared A minus sine squared A. Okay. Now, do you know of any formulas that have cosine squares and sine squares in them? Like this one. So we can replace some things, right? We could say, well, sine squared is really 1 minus cosine squared, isn't it? So we could say this is cosine squared A minus 1 minus cosine squared A. A little bit of algebra here. So we have cosine squared A minus 1 plus cosine squared A, and we end up with 2 cosine squared A minus 1. Okay. We could also say that cosine squared of A is equal to 1 minus sine squared of A. So we could replace, right? We could start with cosine squared A minus sine squared A. That was our original statement, right? So this is our original statement. And then we know that this is 1 minus sine squared A minus sine squared A. This is 1 minus 2 sine squared A. All right. So let me just recap and summarize here. So we have sine of 2A is equal to 2 sine A cosine A. Okay. And cosine of 2A is equal to cosine squared A minus sine squared A, 2 cosine squared A minus 1, or 1 minus 2 sine squared A. Okay. Now, these are the two, okay, so the sum and difference ones, it would be nice if you knew them. It would be excellent if you knew them for the quiz that we just had on this. But the double angle formulas, these are formulas, it's going to help you to have this for a very long time, okay? So like, for example, in physics, you're going to study optics. You're going to look at a lens, right? We're going to draw a little thing here. And we're going to separate this out. We'll say this is theta, also theta. So if we wanted to figure out like what's going on at the end of this triangle, that is a sine of 2 theta here. Okay, so it's one of those things where this is going to be useful for you later on. Cosine. Look at this cosine. I memorized one of them, this one. Okay, and then I use the sine squared plus cosine squared equals 1 to generate the other two. Okay, so you don't have to have all of this memorized. All right. You're going to use this a lot in Calc 2. Okay, this is going to come up over and over and over again. 1 second. All right, see, here she is. She's got a little medical condition. We can't get her fixed because she can't take the anesthetic. All right, so she's adorable enough to put up with the noise. Okay, far cuter than I am. So there we go. There you go. Off you go. Come on. Go. All right. So yeah, she's excited. All right. You know, everybody's going to say, she'd have the cat teach it instead. She does not like the camera. She doesn't like being held. That's what she doesn't like. But yeah, we're going to use these. There's a lot of Calc 2 that tends to use this. Okay, and we'll show you why and we get to it. Okay. Again, tangent, we're not going to memorize tangent. You don't have to. Sine and cosine, those are going to be memorized. Okay, if did I pause? I did not pause. Okay, we're live. So tangent of 2a, I think this is tangent squared. So it's it's 2 tangent. It's 2 tangent of a over 1 minus tangent squared of a. I believe that's our formula for tangent. Okay, because it was tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b, and we can do that. But we will look this up before we go off and have to do it. Okay, so you don't have to memorize this one. I will not put it on a quiz. If I did put on a quiz, because I really didn't ask this question, I will put this formula on there for you. Okay, so this is not a thing that I want you to have to deal with. Okay, or at least memorize it. Okay, this one, memorize this one specifically. I would just choose the center. Excuse me, the center one, and I memorize this one. Okay, so there's our little preamble to the problems that we have. Okay, use the given information to find the exact function value. Okay, please don't use a calculator. Okay, rationalize the denominator if necessary. We have sine is equal to 4 over 7. Tangent is greater than 0, which means we are either in quadrant 1 or quadrant 3. Okay, since the sine is positive, the tangent is positive, the only quadrant we could be in is quadrant 1. Okay. So we can just draw a regular triangle. Right? We have a sine of this angle, right? The sine of this angle is equal to 4/7, which means my opposite side is 4, my hypotenuse is 7. Okay, so what we're going to do is we're going to say we have a squared for the adjacent side plus 4 squared is equal to 7 squared. Okay, so this is a squared plus 16 is equal to 49. Subtract off 16, subtract off the 16. We have a squared is equal to 3, and 4 minus 1 is 3. So a is equal to the square root of 33. Okay. So now they want to know a bunch of other stuff. They're pretty much going to have us just memorize or use this formula. Right? We will have a sine, we have a cosine, and we have a tangent. Okay. So actually, I'm going to pause this for a moment to just double check my tangent. So, all right. So yeah, we're okay with our formula. All right. Like I said, every time you're going to be asked about tangent of 2 theta, you will have the opportunity to look that up. Okay. So it's not a formula you need to commit. So we want to know sine of 2 theta or 2a. This is equal to 2 sine a cosine a. Okay. So we're going to say 2. Okay, what's our sine of a? Our sine of a, they told us it was 4/7. Okay, that was nice. So that's 4/7. And then we have our cosine of a. Here's my picture. Cosine of a is square root of 33/7. Okay, so this is square root of 33/7. All right. So 2 times 4 is 8. So we have 8 square roots of 33 divided by 7 times 7 is 49. These are relatively prime, so that's our sine of 2a. Okay, 8 root 33, fraction 8 root 33/49. Oops, 49. I know that 33 is just 3 times 11. Neither of those has a perfect square, so I'm not going to worry about trying to get this out. Okay. Cosine, dealer's choice. What do you please? Okay. Cosine of 2 theta, 2a. I like the center one more than I like the other ones. Like why? Like because I like the center. So what is easier to memorize for me? Because there's also a difference in 2 squares. So that's the only reason I have a preference to the center one. You can pick whichever one you have a preference to. Like I like positive numbers. I'm picking the first one. That's fine. Okay, so our sine is going to be 4/7. Okay, so we're going to have 4/7 squared minus what's cosine? Cosine is square root of 33/7. So we have square root of 33 squared over 7 squared. Okay, so we're going to have 33, right? Because square root 33 squared, okay, over 49 minus 16/49. So 33 minus 16 is 17. Yeah, sounds about right. So 17/49 positive. Okay. So there we go with that. Okay. And then for so it's 17/49. Go ahead and take a look. Now you don't have to take a square root anymore because that's the formula, because it has the squares in it. Okay, so you don't have to do any of that. Tangent of 2 theta equals 2 tangent of a divided by 1 minus tangent squared of a. So we're just going to go back up to the top and say this is 2 times. Well, actually, we actually have an easier way to go too, because we already know. Well, we'll do it at the end. Okay, we have tangent opposite over adjacent, right? So that's going to be it's going to be 4/√33. 4/√33. all divided by 1 minus 4 over root 33 squared. Okay, so what is this going to be? This is going to be 8 over the square root of 33. Okay, and then we have 1 minus 16 over 33. Okay, so what is 33 over 33? It's 1 minus 16 over 33. Then we have 8 over the square root of 33. We'll get back to that. So this was 17 over 33. That's a 33. Okay, divided by 8 over the square root of 33. Okay, so here's what we have. We have 8 over the square root of 33 divided by 17 over 33. How do we deal with this? We invert and multiply. So that's 8 over times 33 over 17. So here's 33. We could do that, right? We could break 33 up into the square root of 33 times the square root of 33 over 17. So what we did is we turned this piece into this one. Do you see anything that cancels? That's why we did that. So this one will cancel with this. We have a clean 8 root 33 over 17, and we're going to call that a day. Or you could be clever too. Well, either way you do this is fine. We know that sine of 2a over cosine of 2a is equal to the tangent of 2a, right? Sine over cosine is equal to tangent, same angles. What was our sine of 2a? Our sine of 2a was, that was the first one we did. That one was 8 root 33 over 49. So this is 8 root 33 over 49. What is the cosine of 2a? That was 17 over 49. So what we have here is 8 root 33 over 49 divided by, that's this one right here, and this is 17 over 49. So this is 8 root 33, 49, times 49 over 17. Hey, would you look at that? Feel pretty comfortable that we got the right answer here. Okay, so this is going to be 8 root 33 over 17. Is that what we wrote down before? 8 root 33 over 17. All right, feels pretty good. All right. Check your answer and call it a day. Okay, so there's a lot of problems like this. This is fine. This is effectively the same problem we just did, except that cosine is negative, but cosine is negative, but sine is positive. That's going to happen in the second quadrant. So when I go to draw my picture, I'm going to draw it in the second quadrant. Okay. So let's see here. Okay. Use the given information to find the exact function values. Great. Simplify as much as possible. Okay, we can do this one. I kind of like this one because it starts off with a secant. We don't have anything with secants in it, so we're just going to have to deal with that. Okay. So what do we have? We have secant theta equals 12 over 13. Oh, I'm sorry, 13 over 12. Okay. And we know that theta is in quadrant 2. Okay, so theta is in quadrant 2. Nope, theta is in quadrant 1. Okay, so nice triangle. All right. Secant is related to cosine. So we know that secant is equal to 1 over cosine. Okay, so we have 1 over cosine is equal to 13/12. We're going to take reciprocals of both sides. So that is equal to, write that, equal to cosine theta is equal to 12/13. Okay, or you could cross multiply. You're going to get the same thing. Okay, I took reciprocal both sides, but you could also cross multiply. That's fine. Whatever you feel safer with, that's what I want you to use. So this is 12. Okay, this is 13, adjacent over hypotenuse. I know that one by inspection, but let's go ahead. So we have 12 squared plus b squared equals 13 squared. 144 plus b squared is equal to 169. B squared is equal to 169 minus 144. So we go ahead and do that. We end up with 25. And b squared is equal to 5. I'm sorry, b squared is equal to 25, so b is equal to 5. Okay, if you ever thought, wow, being a math teacher looks so glamorous, I think I'm going to pick that. Okay, there is a website called Pythagorean Triples that has, like, the first couple are the very common ones, but like 3, 4, 5 triangles, or 5, 12, 13 triangles. Okay. So it just gives you Pythagorean triples, so you have a real easy way of generating these numbers that don't have like weird square roots in them, because the first time you're going to give this to if you're teaching Pythagorean theorem to elementary school kids or middle school kids or wherever you learn it, you don't want to give them things that have like a whole bunch of weird square roots in it. You want to give them nice numbers. Okay. When you guys go off and taking statics, if you have to come up with your own problems using lengths or forces that are Pythagorean triples, will let you break those triangles down a lot easier. When you have to get the sine of something, it's going to be a very nice number, okay, because they're just going to be integer ratios. So, all right, now we want to know, what is the sine of 2 theta? Well, this is equal to 2 sine theta cosine theta. Okay, so this is 2 times 5 over 13 times 12 over 13. Okay, so what do we have? We have 5 times 12 is 60. Okay. 60 times 2, 120. Or we have 2 times 5 is 10. 10 times 12 is 120. 13 times 13 is 169. Okay, we have cosine of 2 theta. Okay, so we're going to have cosine squared theta minus sine squared theta. So our cosine is 12/13 squared minus 5/13 squared. Okay, so we have 144 minus 25 all over 169. Because we just add, I knew they were going to have common denominators, so I just added them. All right, so what is 144 minus 25? So what are we going to end up with? We're going to end up with, I subtract 1 here and then add 1, it'll still be 0. So we'll say 144 minus 24, and we're going to add 1 at the end, so that's 0. That is 12, 120 plus 1. So we end up with 121. That's not right. Still the old way, sorry. Subtract 1. We're going to subtract 1 from the other one too, I guess. Okay, so I should have subtracted 1 from 144, but that's not going to help. That looked a lot better. 169. There we go. Okay. So, tangent. Okay, and again, you can do tangent either way. You could say, well, I'd like to do tangent as a sine of 2a is equal to sine of 2a over cosine of 2a. This is actually how I recommend you do it, because we've already gone through the work. Okay, but this is 120 over 169 divided by 119 over 169. So we can figure out that complex fraction. right, which is equal to 120, 169 times 169 over 119. Those cancel, so we have 120 over 119. Okay. 20 over 119. Okay. On all the empty boxes. Oh, we didn't do these. All right. So sine, our sine is 120 over 169. And our cosine was 119 over 169. Okay. Okay, there we go. Okay. So we have over here. Verify the identity. You're going to see a lot of these, by the way. Okay. You are going to see a lot of these. So we'll validate it in a moment. We'll just kind of get a rough sketch of our answer here, and then we'll slow down and plug it in. So we've got sine of 2 theta over sine of 4 theta equals 1/2 secant of 2 theta. There's a 2 theta over here. I don't need to turn this into a single angle because our answer looks like it's in 2 thetas. We don't have a 4 theta. So we're going to have sine of 2 theta, and then we're going to have sine of 2 times 2 theta. Okay, so we have the sine of a double angle. Okay, it's like 2 times a double angle, but it's still 2 times an angle. Okay, so we're going to say this is sine of 2 theta. And then we have 2 sine of 2 theta, that's this one, times cosine of 2 theta. Okay, one of the two thetas cancel, one of the sines 2 theta cancels out. Okay, so we have 1/2 times 1 over cosine of 2 theta. What do you suppose that is? That's secant of 2 theta. Okay, so I think that's what we wanted to prove, wasn't it? So let's make it pretty now. Okay, so we're going to say that this is, we need a fraction, I think. Fraction. So we're going to do sine of 2 theta divided by 2 times sine of 2 theta. Oops, one down here, we're still not done yet. Do they need parentheses? Oh no. Cosine of 2 theta. Okay. It's like rule, we used sum difference. No, we used double angle. Okay, we used double angle. Validate. Okay. So now we're going to say this is 1 over. We have 2 cosine of 2 theta. Okay. And the rule was that we used some algebra here because we canceled some stuff out. Okay. And then we're going to have 1/2 times, oops, I don't want that, I want times. Are we allowed to do times? We are. 1 over, no. 1 over cosine of 2 theta. Okay. And what do? We use some algebra. Okay. Oh, validate. I didn't want to select the answer yet. And this is 1/2 secant of 2 theta. Okay. And this was a reciprocal rule because we went through and did that. Okay. Validate. And we are done. Okay. So you just have to be careful because the book is very particular about doing one step at a time and being able to justify that step. Okay, so it's good practice, but humans usually think a little bit faster. Okay. Doing more of these is just going to help, right? It's just going to help you. So I would recommend do as many of these as you can. Okay, this one. I'm not happy with this one, but all right. All right. So here we have a cosine to the fourth of 3x minus sine to the fourth of 3x. Quite honestly, how do we say this is cosine of 6x? I almost want to start on the right-hand side here because what I'm saying here is a cosine of 2 times 3x. We have a double angle formula we could deal with. I don't think it's quite going to help because I know I'm going to run into problems with that. Okay. We also have 3 cosine of 3 times 2x, where we'd have to do a sum of angles kind of a thing, but since our arguments are going to match, I'm not quite as happy with that. Okay. So what can we do with this? We can identify this as a difference of squares, right? This is cosine squared 3x minus sine squared 3x times cosine squared 3x plus sine squared 3x. Okay, you see it's a difference of squares. What's sine squared plus cosine squared equal to? That's 1. Okay, and then we have cosine squared of 3x minus sine squared of 3x. Notice what we have on the other side here. Okay, this is going to be cosine of twice 3x, double angle formula, okay, which is cosine of 6x. Okay, so let's see if we can make this pretty. Okay, so we're going to have parentheses cosine squared 3x plus sine squared 3x, okay, times cosine squared 3x minus plus minus sine squared 3x. Okay, let's check. So it's the rule we used algebra because we got difference of 2 squares. Okay, got it. All right. Next thing we're going to do is we're going to take care of this. We're going to say this is cosine squared of 3x minus sine squared of 3x. Okay, so we just identified that this piece here was 1. We just have this part left. Select rule, Pythagorean. Let's see. Oh, we took it. Okay. So now we're going to say this is cosine of, no, just the 1 of 6x. 2 times 3x. Next rule, we're going to say double angle formula. My fingers are crossed. Didn't like it. 6x, double angle. Proof is complete. Didn't have to do that step. Okay, great. Check answer. Ta-da. Okay. So those are a lot of fun. Okay. Oh. All right. You are very likely to see a problem like this on a quiz. Okay. So before we get started with that, there's something called triple angle formulas. Okay. This is 3. Sorry. This is called triple angle identities. I have put a triple angle identity on a pre-calculus quiz since I started teaching the class. So it's been there for like 5 or 6 semesters now. So if I were you, I would go ahead and take a look at those. Okay. So here we go. We have cosine of 3x. We're going to do one of them right now. Sine of 2x. We're saying that this is 1/2 cosecant x minus twice sine x. All right. So what we're going to do first is we're going to make the observation that 3 is equal to 2 plus 1. Okay. So we've got cosine of 2x plus 1x over sine of 2x. Okay. And now we're going to separate this out. So we're going to say this is going to be cosine 2x cosine x minus sine 2x times sine x, right? This is our A and our B. So cosine, cosine, cosine minus sine, sine. And divided by sine 2x. Okay. The reason why I'm waiting is because this step was a sum of angles step. This one's going to be a double angle step. Okay. So the cosine of 2x. Okay. Look, we've got something that's related to a sine, something that's related to a sine. All right. When I pick my cosine of 2x, there's 3 options. There's one with just sines in it, one with just cosines in it, and one that mixes and matches. So cosine of 2x, we're going to pick the one that just has sines in it because look what happens on the other side here. Okay. So what we're going to do, I'm wondering if I could be a little bit more clever about it. I don't have a squared, I can't be clever. So this is 1 minus twice sine squared x. All right. So we have 1 minus 2 sine squared x, okay, times cosine x minus sine of 2x, okay, times sine x. All right. So what we're going to do now is we're going to go ahead and apply our double angle formulas on the sine 2x's. So we have 1 minus 2 sine squared x. Actually, I meant to do this on the last step, but so be it. Minus 2 sine x cosine x times sine x. That's this one. All over 2 sine x cosine x. Do you see that the first, the numerator, the terms in the numerator both have a cosine x in them? It's going to be a sine squared, isn't it? Right? So 2 sine x times sine x. It's going to be a 2 sine squared x. Okay. Now we have a cosine x, because this cosine x times 2 sine x. All right. Cosines cancel. So here we have 1 minus, we have minus 2 minus 2, we have minus 4 sine squared x over 2 sine x. So now we're going to go ahead and say this is 1 over 2 sine x minus 4 over 2 is 2. Sine squared over sine is sine x. 1 over sine x, that is the cosecant. So this is 1/2 cosecant x minus 2 sine x. Is that what they wanted us to prove? It is what they wanted us to prove. Okay. So that's how we're going to go ahead and justify this. Okay. Since this video is already running a little long, I'm going to go ahead and stop there. I'll leave, I'll do the math book thing. Leave the details to the reader, okay, to go through and do this. But this is a sketch of it, okay? Those are the steps you want to make. We just have to make sure that we are selecting the correct rules to deal with everything, okay? So one step at a time, okay? That way it doesn't get mad at you, and we can go from there. So we'll call out, and we'll pick up next time with start with number 8 here, and maybe number 9. Okay, but we're done.